That the cause, and in this video we'll be looking at nitrogen 4 oxide. So this is probably going to be the last oxide of nitrogen we'll be looking at before we move to triazonitrate 5 acid later. So nitrogen 4 oxide is NO2 gas. That brown gas, that popular brown gas that we'll be talking about is nitrogen 4 oxide. It's a reddish brown gas and it's always produced when you heat nitrates of heavy metals in air. It gives you a brown color nitrogen 4 oxide gas. How do we produce NO2 in a laboratory? It's produced by heating lead 2 triazonitrate 5 salt to a very high temperature. However, you can use any other compound. You can use silver triazonitrate 5. You can use iron nitrate. You can use any other nitrate. You can use calcium nitrate. You can use magnesium nitrate. But lead nitrate has been specifically preferred over all other nitrates because its crystals does not contain water of crystallization, which might interfere with the preparation of the NO. Don't forget that NO2 is an acid anhydride. It can dissolve in water, as I've said, under nitrogen cycle. So you don't need a nitrate salt that will produce water of oxidation first before you get your gas. So because of that, that is why lead 2 triazonitrate 5 has been a major source of production of NO2 in a laboratory because it does not contain water of crystallization. And you can see the equation on the screen. 2 lead 2 triazonitrate 5 will give us 2 lead 2 oxide plus oxygen plus 4 moles of nitrogen 4 oxide. And if you take notes, you are going to observe that it is 2 gases that are produced in this equation: oxygen gas and NO2 gas. So you have to separate the 2 gases. That's why if you look at the structure of the laboratory setup, after heating the lead 2 triazonitrate 5, it gives us 2 gases that are passed through U-tube. Now the U-tube is placed inside a freezing mixture. Freezing mixture is usually a mixture of ice and water. It's very ice and salt. It's usually very cold, such that any gas that can liquefy easily, when it gets inside, it turns to liquid. And NO2 is such gas that can liquefy very easily. So when the 2 gases, NO2 and O2, passes through the freezing mixture, NO2 gas, being more easily liquefiable, turn to liquid in the U2, and oxygen gas escapes from that U-tube as a gas. Since it will not easily liquefy, you need a very low temperature, minus 183 degrees Celsius, to even begin to think about liquefying oxygen. So it will not liquefy in a freezing mixture, but NO2 can easily turn to liquid in a freezing mixture. So that freezing mixture will trap NO2 gas as a liquid, whereas the oxygen gas will just go out of that U-tube. So what happens when lead 2 nitrate is heated strongly? This question has always appeared in WAEC questions, in examination question. It has always appeared and present itself many times. What will be your answer when this question is presented to you in exam? When you heat nitrate salt, all of them generally, the first thing that they do is they crackle. They crackle means they decrepitate. They make cracking sound. They make cracking sound and melt and decompose. Those 3 things will be undergone by all nitrate 5 salts that you are heating strongly. They will crackle, they will melt, and they will decompose. But for the case of PbNO3, it decomposes to form brown fumes of NO2 gas and a reddish brown residue of lead 2 oxide. Lead 2 oxide is a substance that is brown when it is hot and turns yellow when it is cold. That means the compound is thermochromic. That's thermochromic nature of lead 2 oxide. It has two different colors depending on the temperature of the substance. Lead 2 oxide is brown when it is hot and it is yellow when it is cold. So you are going to observe these things that is going to crack, it will crackle, it will melt, it will decompose into brown films of NO2 gas and reddish brown residue of PBO. The residue will turn yellow on cooling. So the gases that are formed in our operation of NO2 gas, I thought that they are immersed in a U-tube where the NO2 gas become liquefied as a green liquid. The color of NO2 gas will be green if it is not pure, but yellow if it is pure. So the oxygen that is produced alongside the NO2 gas will escape in the U-tube as a gas because it will not be liquefied at the temperature of freezing mixture. What are the properties of NO2 gas? The physical properties of NO2 gas. Number one is a reddish brown gas with irritating smell. The smell is irritating, the color is reddish brown. It is poisonous. It is poisonous. It's not a gas you can play with. So if you are preparing it in the laboratory, you must wear your gas masks or prepare it in a film cupboard because it is poisonous. It turns down blue liquid paper red and dissolve in water to form acidic solution. NO2 is a mixed anhydride. When it dissolve in water, it give you mixture of two acid. Hence, you call it a mixed anhydride. It give you HNO2 and give you HNO3. Those are the two compounds you are going to get when you dissolve NO2 gas inside water. It easily liquefies into yellow liquid if it's pure. If it's not pure, it will be green at 21 degrees Celsius. So you can see the reason why it can be trapped into a freezing mixture, and it is highly denser, much denser than air. What are the chemical properties of NO2 gas? Number one, when heated, it exists in two molecular form. At low temperature, it exists mainly as a yellow liquid, the one that you saw inside the freezing mixture, as dinitrogen 4 oxide, N2O4. That is the nature of NO2 gas at low temperature. But when you warm it, the N2O4 will dissociate into a brown NO2 gas. So at high temperature, it's a gas, NO2 gas. At low temperature, is a liquid, yellow liquid, N2O4 liquid. So when the temperature rises, the color of the N2O4, you know, it being yellow, the color is light. But when the temperature rises, the color intensifies, the color darkens and deepens to brown as the N2O4 dissociates into 2NO2 gas. Supposed to be NO2, not NO, 2NO2 gas. The color is reddish brown. The dissociation will be complete at 140 degrees Celsius. If you keep eating NO2 gas above 140 degrees Celsius, the NO2 gas itself begins to separate and decompose into nitrogen, oxide, and oxygen gas. Hence, if you want to achieve transition between N2O4, that's the nitrogen 4 oxide, which is pale yellow, to NO2, you heat it and don't allow the heat to surpass 140 degrees Celsius. So combustion, NO does not burn. It doesn't burn, but it supports combustion of a brightly burning substance. If you burn sufficiently enough to be able to decompose the NO2 into oxygen, then you can continue to burn in that NO2. But if you don't burn with sufficient heat to accomplish this feat, you cannot continue to burn in NO2. NO2 is reduced by nitrogen when heated with copper or iron. As you can see, the equation 4Cu plus 2NO2 will give us CuO plus N2 gas. It can also be reduced to nitrogen 2 oxide if it is reacted with hydrogen sulfide or carbon 2 oxide. As you can see in this place, H2S plus NO2 give us water plus NO plus sulfur. So the H2S is oxidized to sulfur, the NO2 is reduced to NO, and water is also produced alongside. CO also can be oxidized to CO2 with the presence of NO2, not NO gas. Presence of NO2, which will now give us CO2 to plus NO gas. With water, NO2 is a mixed anhydride. It produces mixture of salt with acid and mixture of water, mixture of acid. It produces mixture of salt with bases and produce mixture of acid when dissolved in water. It produces mixture of dioxynitrate 3 acid and trioxynitrate 5 acid when it is dissolved in water. The equation is given in the middle of the screen. If the oxygen is in excess, only HNO3 will be obtained, because the HNO2 that is formed here will be oxidized to HNO2. So in the presence of oxygen, you will not see HNO2 at all. It's because it will oxidize back to HNO3. As you can see in this place, HNO2 plus oxygen gives us HNO3. So if you want to produce HNO3 from NO2 gas, dissolve it in water using excess oxygen, you are going to get HNO3, and this method has been used industrially to produce HNO3 in days gone by, and it's still being used even since now. So because NO2 is a mixed anhydride also, it can react with alkali to form mixture of 2 salts. For example, if you react NO2 with potassium hydroxide, it gives us KNO2, KNO3 and water. Usually an acid should react with an alkali to form salt and water, a salt and water, but NO2 will form 2 salts and water because it's a mixed anhydride. So this will be the end of oxides of nitrogen. God bless you real good. Amen.